Hello friends, today we are starting with a new course like IT Essentials. In this IT Essentials, we are going to discuss about a few topics. Okay, like basic concepts on hardware and system software concepts, some basically computer architecture we are going to discuss, and also object-oriented paradigms and database management systems and few testing softwares we will be looking into this course. So coming to the course, let's start. So now I'm going to tell about computer hardware and system software concepts. So in this we'll see about few. So what is a computer? So computer is an electronic device used to store and retrieve and process data. To process data, a set of instructions need to be given to the computer, right? So, and what is a program? So program is a set of instructions. Okay, so when you club a group of when you uh, group some instructions into a place, it is called a program basically. So you can write in other terms like computer is a machine which solves problems for people, written as program. A program is a sequence of steps stating how to perform a task. So for each step, the algorithm and a logical operation is done. For each operation, a different set of control signals is needed. That is an instruction. An instruction can be machine language instruction or assembly language instruction or even high level language instruction. So basically a program can be written in three languages, either in a machine language, assembly language or a high level language. So depending on that instruction, there will be set of control signals which take care of what to do by when we got some instruction. So hardware. So what is the hardware in this? So hardware is like basically something that is tangible. That is example like CPU, memory, input output devices, bus, etc. Okay, bus is like a connecting cords to transfer data. So a software is a collection of programs. So it trigger the question to identify the differences between software, program, function or function or procedures, etc. So basically there are different types like what is a software, program, function. Like basically we think that all of them are similar, but each has is slightly varying in behavior. Okay, so software is mainly of two types: system software and application software. So programmers such as compiler, linkers, loaders, assemblers are called as system software. So in a better way of understanding, we can say a system software is the OS where like Windows, Linux, Ubuntu and all Linux, basically Ubuntu will come under Linux only, or Mac OS, right? So these are all OS which helps to handle the applications that are present inside it. So that is like those applications will run using application software or made using application software. Okay, so in this in our technical terms, we can say that programs such as compilers, linkers, loaders and assemblers are known as system software, whereas application software provides a solution to user applications by making use of system software. So application software uses the system software to run. So example, banking software, payroll software, etc. A firmware is a software embedded in a hardware during manufacturing. So this is basically inbuilt like dumped while manufacturing. Example, home appliance, etc. Home appliances, etc. Now coming to the computer architecture, is concerned with the structure and behavior of computer as seen by a user programmer. It includes attributes such as instruction formats, addressing modes, instruction sets and input output mechanisms. So basically these are the main fundamental parts involved, or attributes basically involved in the system computer architecture. So we'll see what formats, addressing modes and all. So architecture refers to how various components in a computer are organized and design aspects of a computer. So how it is organized and designed basically, which that is referred by architecture. So computer organization is how features are implemented, typically hidden from the programmer. So basically an example, control signals, interfaces and memory technology, etc. It is basically concerned with the way the hardware components operate and the way they are connected together to form a computer system. So basically this computer organization will mostly depending on the hardware, where how the hardware is connected together. Okay, And an instruction consists of an opcode always, along with some additional information such as where the operands come from, or where the final result to go to, etc. This thus they can be 0, 1, 2, or 3 addressing presents. So basically, let us take an example of add, where add is an opcode. Okay, this opcode will have other information like registers: add r1, r2, r3, or add r1, r2, or add r1. So sometimes there are few other instructions with that which doesn't have any addresses, registers itself. Okay, in these three examples that I have told, that add r1, r2, r3, like r1 plus r2 results stored in the r3, and r1, r2 stores r1 plus r2 results stored in r2, and r1, if add r1 is there, only one operand, then the r1 will be added to the accumulator and stores in the accumulator. So different mechanics have different instruction formats. Okay, so addressing basically refers to the way in which the operands are specified in the instruction. These are different ways in which the bits of an address field can be interrupted to find the operand. Addressing modes refer to these data different ways. Computer architecture. Main components in a computer architecture. So basically hardware, software, and a firmware. Right. So now coming to the organization of a simple computer. Here we can see basically a memory where there will be a central processing unit, a memory or main memory, input output devices, and bus. So these are few all like one. Let us take this is a CPU, the central processing unit, and let us take this is a main memory, and these are all hard disks and CD drives, hard disks, and this can be interrupted as, or keyboard can be interrupted as an input or output devices. So these are all connected using some bus. Okay, these are all buses. Okay, you can see there are few of double-ended and are single-ended. So basically double-ended means they can use like input and output, both way the data will transmit here on the here also. But whereas the keyboard, here the only data is coming from keyboard into the system, not in the reverse direction, right? So that's what. So now coming to CPU. CPU is a processor where is the brain of the computer. It functions for fetching of instruction from memory, examine, and execute. Consists of three functional units like control unit (CU), arithmetic logic unit, and registers. So this is how our units. The CPU is a part of a computer that performs the bulk of a data processing operations. Its main function is to execute programs stored in the main memory by fetching the instructions, examining them, and executing them. So basically it will fetch for the instruction, and it executes that, and basically it fetches the instruction and examines it and executes that. So when it comes to in detail, like CPU functional units. So in the CPU there are three functional units like control unit, arithmetic logic unit, short formed as ALU, and registers. So this control unit can be fetches the instruction from memory and interrupts the instruction, interprets the instruction. So that means it will fetch where the like from the memory it will fetch the instruction, and it will identify what it has to do. And now coming to ALU performs arithmetic operations and performs logical operations. Okay, so arithmetic and logic we'll see the difference. Arithmetic is like addition, multiplication, division, and all. Subtraction. Logical operations is like comparisons, like greater than, less than. Basically it comes under boolean. Okay, boolean values. So now registers. So registers are very high speed memory units in the CPU for storing very small amount of data. Examples of registers are program counter (PC), instruction register (IR), and memory address register (MAR), memory buffer register (MBR), and accumulator (A). So accumulator is like which stores the recent results, and memory address register and memory buffer registers will store address. MAR stores the address, and MBR stores the result. So that is present at a particular location basically. And instruction register stores the instruction, and program counter will points to the current location of the instruction. So let's see. Now these are few examples of CPU where let us take two companies like Intel processor and Motorola processor. So Intel processors will be like 80s, all 80,088, sorry, 8088, 80286, 80386, 80486. Like these are Pentium and then Pentium processor. Then Motorola is like 68,000, where 68,000, 68,020, 68,030. Okay. Now coming to the memory, a minute. So we'll have discussed it till here about examples of CPU. In the next video we will see about memory and further what are the memory and what are the components present inside a memory. Thank you for watching. Like, share and subscribe.